Hello everyone, in this video I'm going to be talking about how to calibrate a microscope, more specifically an optical microscope. Now, if you've used the microscope, you'll see that it has multiple lenses on. You see there's like a ×4, a ×10, so you can magnify particular images. But it's very difficult without a calibrated microscope to actually understand and see how large or how small the specimens that you're looking at and observing are in real life. So the point of calibrating a microscope is to make an accurate measurement of what you're looking at. So ultimately, when making any kind of microscopic measurement, it is important that the microscope is calibrated. It means that at any given magnification, you can work out actual sizes of a specimen. That's the key thing. And you do it with an eyepiece with a linear scaling. Now, this eyepiece scale is called a reticle or graticule. So just make a note. So you use an eyepiece called a reticule, or it's also known as a graticule. Now, the reticle can be used to measure any planar dimension in a microscopic field. So if we were to zoom in, if we were to take this part, for example, here, this would be our eyepiece, that's our reticle. So if we were to look inside there, what we'd notice would be a series of lines on the scale. So if you look down, if we're imagining here's sort of the outside of the lens that you can see, you'll notice a scale with divisions, and it may look something like this: 10, 20, 30. So we're going to use that with what's called a stage micrometer. Now, a stage micrometer is simply a microscope slide with a finely divided scale marked on the surface. The scale is of a known true length, and you use it to calibrate the microscope with the eyepiece. So you have what's called a stage micrometer, and it's a very rough sketch, but it looks just like a typical slide you'd use. And in the middle here, what you'd see let's colour this in. What you'd see in the middle, if you put this under a microscope, is a very small scale. It looks a bit like this. So you have a slide, and in the central part that you're going to observe, you can see a very finely divided scale, very similar to the one in the eyepiece. So what you imagine, clearly, if you have the slide placed on the stage here, and you're looking down the eyepiece at the same time, you'll actually see the two scales almost overlap. One will appear on top of the other. So you're almost superimposing one scale on the other. So it may look something like this. So we'll reduce this down in size a little. It may look like this. So you'll see the eyepiece scale here. So let's put that in place: 10, 20, 30. And then if we just colour in red the scale that you'd see on the stage micrometer, now this isn't actually drawn to scale, but you should be able to see what I'm going for here. So it's as if those black lines are superimposed over the red ones. Now I'm just going to give some of the red lines here a scale. So we'll say that on the black line that's 20, I've got a 30 here, 40 there. we'll say that this one on the black line says 50, etc. We'll say it goes all the way up to 100. Now when you calibrate a microscope, you calibrate it at a specific magnification. Now, all you have to do is line up those divisions on the eyepiece with those of the stage micrometer and kind of work it out by ratio. So I'll just explain exactly what I mean and how this is done, how we're going to calibrate. So let's imagine that our stage micrometer is divided into, so we're going to say our stage micrometer is divided into 100 sections. So 100 of those red lines that I've drawn down here, and we'll say that each one of those sections is 0.1 millimeters. Now, if we look at the black lines, the big heavy lines, we're just going to focus on the 10 to 20. So let's look at those eyepiece units. Between 10 and 20, there's a difference of 10. So we have 10 eyepiece units. So we've got a division here of 10. Now those 10 eyepiece units relate to 30 sections on the stage micrometer, because you can see the 10 here is overlapping the 20, and this 20, this black line where we have 20, is hitting the red line on 50 on the stage micrometer. So we have in that space of 10 eyepiece units, 30 stage micrometer divisions. And what we want to know is what one eyepiece unit is, so that if we put anything in the microscope at that magnification, we can see what one eyepiece unit would represent. So if 10 eyepiece units is 30 divisions, then one eyepiece unit must represent 3 divisions. Now you know because we've said over here that each division on this stage micrometer represents 0.1 millimeters. So 3 divisions would therefore represent, on this scale, 0.3 millimeters. And that is the answer we're after, 0.3 millimeters. So what that means is that whenever we now put anything at this particular magnification under the microscope to look at, when we see one eyepiece unit, that represents 0.3 millimeters in real life. So every one unit on the scale is 0.3 millimeters in real life whenever we use that eyepiece. And it's quite easy if you change the magnification. So if you change the objective lens, what you're looking at, so to an even greater magnification, you just have to recalibrate the microscope, doing the same steps. Look down the eyepiece, superimposing those lines on a stage micrometer, and just by almost like ratios, try and line up all those divisions as we've done in this example. So we had 10 eyepiece units, the 2 black lines at 10 and 20, covering 30 divisions. So one eyepiece unit represented 3 divisions. And if you're told how many sections are on the stage micrometer and what each section size-wise is worth, then you can easily deduce how big a specimen is that you're looking at. And that, quite simply, is how you calibrate a microscope, using an eyepiece called a reticule or graticule and a stage micrometer of a known length. And you just look at calibrating it by matching those scale divisions with one another. Okay, hope all that helps.